Please subscribe and click the hype and like button to get more content like this. Before we start, a quick disclaimer. Everything demonstrated in this video is strictly for educational purposes. To show you how to protect yourself, all demonstrations are performed in a controlled lab environment on our own testing devices. We never target real users, and using this knowledge to gain unauthorized access to actual people or systems is strictly illegal and unethical. In this demonstration, we'll explore how to use Nmap to detect low-interaction honeypots and the techniques to effectively bypass them. We'll cover several techniques, which we will demonstrate step by step. To begin, open your Kali Linux terminal. Our first technique involves operating system detection and service version scanning to identify potential anomalies. Honeypots often attempt to imitate real operating systems, but they frequently contain subtle inconsistencies in their OS fingerprints. If Nmap is unable to confidently determine the operating system, it could suggest the presence of a honeypot. To test this, enter the following command in your terminal. Nmap -O -small s capital V, then enter target IP address 192.168.56.1. Press enter. Here, -O enables OS detection and -small s capital V triggers service version detection. Once you run the command, Nmap will start analyzing the target to determine its operating system and running services. If the output includes something like no exact OS matches for host, test conditions non-ideal, service info :OS :Windows, CPE :/o Microsoft :Windows, it indicates that the system might be running Windows, even though Nmap isn't entirely certain about the operating system. This method helps detect irregularities that could point to a honeypot. Since this is a Microsoft Windows version, it is unlikely to be a honeypot. This is how we can gather clues to detect honeypots. Now, clear the terminal by typing clear and pressing enter. In the next method, we'll decoy packets to confuse the target's logging systems. In your terminal, type Nmap -D $RND: 10, then type the target IP address 192.168.56.1. Press enter. This sends 10 random decoy packets to the target IP address. These decoy packets simulate different sources, helping to mask your actual IP address. Some honeypots may raise alerts or respond oddly when decoys are used. So if you notice strange output or warning messages, it could suggest the presence of a honeypot. And you can bypass this using several techniques. As the scan runs, we can see that the synchronization stealth scan timing indicates approximately 37% completion. This is a large scan because we are sending 10 random decoy packets. If your target IP range is large, the scan will take more time to complete. Here, the stats shows elapsed time is 10 seconds, but scanning may still be in progress with no results yet. 0 hosts completed. Now observe the updates showing progress, such as 52.3%, followed by 52.38%, and then 52.4% completed. You can scroll up in the terminal to review earlier output, especially if it scrolls by too quickly. We can see 49 seconds have elapsed since the process began. Eventually, the results will appear. For example, 49.72% completed. You may also encounter a warning message, such as retransmission cap hit 10. This warning means that either a honeypot has detected your scan or the system has reached a limit during decoy packet transmission. Using the -D flag in Nmap helps detect honeypots by analyzing how the system responds to decoy traffic. To end the task, press Ctrl+C in the terminal to stop the scan. Now let's clear the screen using the clear command and pressing enter. Now, let's look at our next technique. Using a randomized source port, enter the following command. Nmap -source -port 53, then type your target IP address 192.168.56.1. Then press enter. After entering the command, wait for Nmap to generate output. Some honeypots only accept traffic that appears normal. Port 53, associated with DNS, is often considered trustworthy. Here we can see port 53 isn't active. Instead, the scan reveals TCP port 135 is open and used for Microsoft RPC, MSRPC. TCP port 139 is used for NetBIOS SSN, and TCP port 445 is used for Microsoft ES. This output suggests the system is likely legitimate, as simplistic honeypots often do not emulate these services accurately. To practice safely, use the IP address of another virtual machine within your own lab environment. Now, let's try our final method, which is packet fragmentation to evade basic detection systems. First, type clear to clear the terminal screen. Then, enter this command, nmap-f, then enter target IP address, 192.168.56.1. Press enter. This option breaks the scanned data into fragmented packets. Some honeypots may not be able to properly reassemble or analyze these fragments. You'll likely see similar responses as in earlier scans, providing another clue about how the system reacts. So packet fragmentation can be an effective technique to bypass simpler honeypot detection mechanisms. That concludes our demonstration on using Nmap to detect and bypass low-interaction honeypots.